Hello EFR 518 students. I have to apologize, I do have a cold and maybe even the beginnings of flu. So we'll go through this. I apologize for the sniffles. So this is exercise 13 and we're going to do the key example in the key. So for this assignment, this is student data collected from cell phone reaction experiment. Average R1, R2, R3, then run an ANOVA with the following data. Include an interaction effect and a 2 by 2. Calculate the effect size for each effect. For the effect size, use eta squared. This is something new for us. And the effect size shown on page 520 of the text. There's eta squared and partial eta squared. It would depend if you're seeing this in your journal articles. Say you're going to ask the question, what do they use in my field? So we're just going to use eta squared. And you can just write it eta dash squared. You don't have to put in the fancy equation. So again, that's 520 of the text. So write up your results in APA. So here are our data. This is the reaction time. So we have talk, hand, and then we have 3 replicates. So this is the distance the ruler felled when they're under these conditions. Students were either talking on their cell phone or not, and they're holding it in their dominant hand or not. So dominant hand is 1, 0 is non-dominant, and talking is 1, and 0 is not talking under this situation. So the premise is that you're going to be able to have more focus on driving if you're not talking on your cell phone. So we want to go ahead and run this analysis. So first thing we're going to do is bring this in the SPSS. And I won't cover that here. We should know how to do that, right? So we're going to bring it in. We have participants, talk, hand, R1, R2, and R3. So we brought the data over. We have variable view and we have data view. So our data is in. So again, we want a 2 by 2 factorial. So we're going to go up to analyze and we're going to say general linear models, univariate. So we went to general linear model, univariate, and we're going to click on that. And hold on. We first have to calculate the average of our 3 drops. I'm sorry. So we're going to go transform, compute variable. So let's call it R underscore 1, 2, 3. And then I'm going to ask for the mean. And we're going to bump over each one of these one at a time and put a comma in between. And then close up a paren. So once that's set, I'll say OK. We'll see here, the data says computed. If we go to our data file, and here's our average, and that's what we want to use in the analysis. So we average these to get one measure, R1, 2, 3. So now we're ready to go to analyze, general linear models, univariate, and our dependent variable, right, is our R1, 2, 3. And our fixed factors are talk and hand. We're going to ask for some plots. So you can put talk over, then hand on separate lines. Then we're going to add that plot, and then we're going to say continue. Now, in the past, we've always asked for the means. Here's EM means. And we needed those for our effect size, our Cohen's d. But today we're going to use eta squared. So we don't really need these, but we'll bring it over so we have them in the analysis. So I'm going to just say continue. And I'm ready to run my model. So I'll say OK. Here's my analysis. So we see we have conditions. We have talk 0, 8, talk 1, 8. and then hand 8 and hand 1. So we have pretty even design. So what I really need for this analysis is the ANOVA table. But here's the 2 by 2, and as you can see, the longer the distance here, the bigger the number, the poorer the reaction time. So we can see hand, red, and then the hand 0, and here's talk 0, hand 1. So we see our longest reaction times are for hand in the non-dominant hand and talking right here. Okay, so I'm going to bring my ANOVA over. Now I'm going to say copy. I'm going to say copy as an image. That's going to allow me to size this a little better. So I'll bring that copy over, and I'm going to paste it right in here. So now we need to write our effect sizes. And here, let's bring that down one. So these are just the eta squares. They have them up here. Okay, so APA for talk. As I see, here's my talk line. And I see P less than 0.05 for SIG. So that is statistically significant. And so to write that up in APA, it has 1 degrees of freedom, and the error is 12. So I'm going to change, this is just some code here I'm adapting. So 1 and 12. And its value is 5.635. 5.635, P less than 0.05. Okay, so my eta squared, I'm going to take my sums of squares. So we think about R squared. R squared is the percent of variation about the mean explained by the model. So here, how much did talk explain in R squared? So it's 560 right here. So the sum of squares for talk. So 5, whoops. Five 60.111, and then the sum of squares total is right here. So that is 32830 period 889. Okay, so then we just have to calculate that out. And that's for talk. Okay, so how about hand? My APA for hand, I see that is not statistically significant. So it's an F with 1 and 12 degrees of freedom. Its value is 0.493. I'm on hand row. So 0. 0 point, oops, okay, I lost that there. There we go. It's 0.493, and then p greater than 0.05, so it's not statistically significant. So the eta squared for hand then is, we're going to look at the sums of squares for hand. It's 49. .0, and over the total. The total is not changing right here. And so that's 32.830.889. Okay, so that's for talk and hand, and now we're going to do hand times talk. So we're going to come up here, hand times talk. We're on this row right here. So its degrees of freedom is 1 and 12 again. So that hasn't changed throughout all these. It's because it was a 2x2 design. The 4.650. 4.650. And we just missed statistical significance of this. So p greater than 0.05. And now the effect size. So we look at hand times talk. It's 462.250. Four, 462.250. 462.250, and then the total 32830. Three, 2, 8, 30.889. Okay, so then we just calculate the effect size, and that's the assignment. That's how we'd write that up. Okay, thank you. You can write it up, and